Now we're going to see an example where we actually have to use logarithmic differentiation in order to do the derivative. So what is this function? Well, it's y equal to x times the square root of x. And I don't know if we've ever actually seen anything like this so far. It's kind of an unusual function. And why it's unusual is because there's variables two places here, in the base and in the exponent. I don't think we've seen anything like this. All right, so let's go through the logarithmic differentiation process to see how this works. So again, first step, we apply the natural log function to both sides. So that's going to give us natural log y on the left, and that's going to give us natural log x raised to the square root x on the right. All right, so we applied the natural log. Step 2, we use our log properties. Now there's nothing to do on the left. There's a little bit to do on the right. So if we look at this, there is an exponent here, and everything inside is being raised to that exponent. So it's x raised to the square root x. So we can take this square root x. We have our log property that allows us to take this exponent, move it outside the log function, and then it just becomes multiplication outside the log function. So we get square root x times the natural log of x. And that's it. We can't simplify this anymore with our log properties. So as it is, this is nice because it gets that variable term out of our exponent. Becomes multiplication, but at least it's out of the exponent. And so now we're ready for our implicit differentiation. Step 3. We're going to do our implicit differentiation. So we've done a few of these now, and this log y on the left always differentiates to the same thing. It always becomes 1 over y times y prime, chain rule. So derivative of the outer log function gives us the reciprocal, and then we multiply by the derivative of y. That's chain rule. All right, so how are we going to differentiate this square root x times natural log? Well, it's a product now. So how do we actually differentiate this? Well, we apply the product rule. So we're going to have square root x times natural log. Let's write down 2 copies of our product. In the first copy, we apply the derivative to the first part. In the second copy, we apply the derivative to the second part. And then we put a plus sign there in the middle. And this is our product rule. So we're doing our implicit differentiation at this step. So it's helpful to kind of keep in mind, up until this point, it's just been some algebra that we've been doing. Now we're starting our derivatives. All right, so there's still some work to do. So we have this square root x term that we need to differentiate. That's not too bad. We can do that. We get 1/2 x raised to the negative 1/2. Then we have natural log x. We can do that. Well, there's nothing to do. It's outside the brackets, so it just stays natural log x. And then we also have this square root x over here, which is outside the brackets, so that just stays the same. And then derivative of natural log x is 1 over x. So we just fill that in. And over on the right side, we haven't done anything over there, so that's still 1 over y times y prime. And that's it with the differentiation. Now from here, we want to solve for y prime. So what do? We multiply both sides by y, and that's to get rid of this 1 over y. We don't want that 1 over y there. We want it canceled. So if we do it to one side, we have to do it to the other side as well. Give myself a little more room there. So the y and the 1 over y cancel on the left. we have y prime then all by itself now. So we've solved for y prime. So when we do this, what are we getting? We're getting y prime is equal to y times 1/2 x raised to the negative 1/2 natural log x plus, and actually we probably could start simplifying this down a bit, but let's at least simplify this down. So this is really x raised to the 1/2 power, and then we're dividing by x. So we could actually write this as x raised to the negative 1/2. So remember, when we divide, when we have a fraction and when we're dividing, we really subtract the exponents. So we have a 1/2 here, and then we're dividing, and the exponent down here is 1. So 1/2 minus 1 is the negative 1/2. And actually, we could probably do some factoring here as well. But this is fine for now. So this is the start of step 4, is we're solving for y prime. Now, we have this y here. We don't want the y. We want to get rid of it. So we want to replace that with what our original function is, and it's that x raised to the square root x. So we just make that replacement. And while we're at it, if we simplify here, always keep an eye out for easy things to factor. So both of these have an x raised to the negative 1/2. So we could factor out an x raised to the negative 1/2. And then we get that. So we have x raised to the square root x. That's what we replaced our y with. And we factor out an x raised to the negative 1/2. Not necessary, but it's usually helpful if we're going to do anything later on. And then the leftover pieces, we're going to have a 1/2 natural log x plus 1. And that's a nice version for our derivative there. All right. So this one, we actually needed to use logarithmic differentiation for. So we're going to talk about this function, a little bit more about these types of functions next.